Good morning. Thank you for coming to Nehru Science Center for this lecture. You know, we are having already one exhibition going on. How many of you have seen vaccine injecting hope exhibition is down there? So, okay. Then before you go back, don't forget to visit that exhibition. Because this lecture, that exhibition together will reinforce so many things, and you will come to know how important vaccine is, why we should take it, or what are the myths associated, how it started, and all that. So you can learn how so many people have contributed in making this, particularly during Corona period, we all suffered a lot, and we were looking for some hope that something miracle will happen and then they will save us from this. So this happened almost in 100 years. Before that, it was 1918 Spanish flu, such a large scale when lot many deaths happened across the world. And after that, this was the time when we faced all this difficult situation. Many of us have lost our near dears during that period. So vaccine is one of the, obviously the hope, and not from today itself, but from the time when we, if you go through this process, you will find that it has always helped. और अभी तो मेरे ख्याल है बच्चों को सबको लगा है ना, आप सबको कुछ ना कुछ वैक्सीन, डर तो नहीं लगता है ना? अभी पहले डर लगता था, पहले भाग जाते थे हम। मुझे याद है जब हम स्कूल में बच्चे थे तो पता चला कि टीका लगाने वाले आए हैं, तो क्योंकि टीका लगाने का एक साइड इफेक्ट जो होता है, जो अच्छी चीज़ मानी जा सकती है कि भाई टीका असर कर रहा है। कभी कभी ऐसा होता है ना कि बुखार चढ़ जाएगा, तो बुखार चढ़ा तो इसका मतलब टीका काम कर रहा है, ये उसका एक इंडिकेशन। लेकिन वो बुखार के डर से जो है भाग जाते हैं। पहले होता था ऐसा, अभी जागरूकता है, अभी तो बहुत कुछ बदला है। अभी सब पेरेंट्स भी, टीचर्स, गांव में भी आप जाएंगे तो मतलब अब तो लोग कार्ड खुद ही बनवा लेते हैं। बच्चा हुआ कि कार्ड बनाया तो खुद जाके कौन कौन से ज़रूरी है, क्योंकि अब हम उसकी महत्वता जो है, उसकी इम्पोर्टेंस जो है, दैट वी हैव अंडरस्टूड. So this exhibition is going on. We have already organized 2-3 lectures. There were a lot of competitions, programs, and its premiere show was in Delhi. Then it happened in Nagpur. Now it has come to Mumbai. It will be open up to 28th of July. After that, it will go to Bengaluru, and from there it will go to Calcutta. That's how it is planned up to year 2025. At each place, it will be almost for 5 to 6 months. So we are about to close. Maybe this is the last month, and in this series of lectures, we have today with us Dr. Tanu Singhal. I will just briefly introduce her and then invite her on the dais. She has a degree in MD Pediatrics from AIIMS New Delhi, also MSc Infectious Disease, London School of Hygiene and Tropical Medicine, London, United Kingdom. She is attached to Kokilaben Dhirubhai Ambani Hospital in Mumbai. As a membership of expert member of pediatric TB and TEP, and then board member of fungal infection study form. She has got award also, Dr. I.C. Verma Excellent Award in the year 2020. Interest areas are obviously COVID-19, tuberculosis, antimicrobial resistance. I think you have heard this. We had, ma'am, one exhibition with the same group on this antibiotic resistance. The title was antibiotic resistance with question mark, end of antibiotic. You know, now that's also a big concern. Superbugs, yeah, superbugs, the end of antibiotics. Superbug का नाम कितने लोगों ने सुना है? सुपर तो सबने सुना होगा, superbug कितने ने सुना है? Superbug is a big concern for all of us sitting here, particularly young generation. Must read about it. Please, after going back, whenever you get time, थोड़ा सा उसके बारे में जानकारी हासिल. We are all going to face this problem. I have already faced, many of us will be facing later. Okay, ये जो दुकान पे जाके एक एक टैबलेट खरीद के ले आते हैं ना, और जो बच जाता है उसको जेब में रख लेते हैं अगली बार खाने के लिए, ये बड़ी ख़राब आदत है. इसके बारे में इसलिए कह रहा हूँ, थोड़ा सा हम बोलेंगे तो नहीं समझेंगे, थोड़ा सा जानकारी हासिल कीजिए आप लोग, ताकि आप रोक सकें उसको. She has published 108 publications in medical journals, index journal, 3 books and 25 book chapters. So we have long experienced person with us. We are fortunate to have Dr. Tanu. I'll request her to come on the dais. And simultaneously, I'll request Miss Anjali Singh from Maratha Mandir Baba Sahib Gaude School. Ma'am, please. Anjali. Yeah. Anjali will welcome Dr. Tanu on behalf of all of us present here with this potted plant. The topic, as you can see, vaccine, past, present and future by Dr. Tanu Singhal. Now over to you, Dr. Tanu, please.
Hello? Yes. So, it's really a pleasure to be here, and I would really like to thank all of you for coming here, and I would thank Dr. Jayanti Shastri for inviting me. And so I'm going to be talking about vaccines, and my first question to, it's not moving. Yeah. So I want to ask you here, what vaccines have you heard about? Can somebody from the audience tell me? Yes? Covishield, yes, so COVID vaccine. Anybody else? Any other vaccine name that you know about? Yes? Polio vaccine, good. Anybody else here? Very good. So obviously there are a lot of vaccines, and I think people have really become aware of vaccines after the COVID pandemic. So we need to first know that how important are vaccines, and actually it is estimated that vaccines have saved 154 million lives in the past 50 years. In Indians, you know, as Indians we understand more in terms of crores. So if I would convert it into crores, it means that 15 crore people have been saved, or 6 lives every minute in the past 50 years. And you know, vaccines actually save babies. So for each life saved, 66 years of life were gained, or 10 billion life years have been gained by vaccines. 20 million people were saved from getting paralyzed. And you have one disease which has been eradicated from the face of earth. Polio is on the brink of eradication. And if you actually look at all the medical interventions till date, whether it is ORS, whether it is antibiotics, the most effective medical intervention till now has been vaccine. तो अगर मैं हिंदी में बात करूं तो जितने भी अभी तक मेडिकल डेवलपमेंट्स हुए हैं उसमें वैक्सीन सबसे ज़्यादा इफ़ेक्टिव है. तो how do vaccines work? So vaccine is basically either an inactive form of virus or bacteria or a weakened form of virus or bacteria. तो इस तरह से the vaccine can either be live or it can be inactivated form, and when it is introduced inside the body, it basically gives rise to it stimulates the immune system. You know, we have an immune system inside. We have these white cells which are called as lymphocytes. So it stimulates the immune system into forming antibodies, and these antibodies remain inside our body, and then later on when any foreign bacteria or virus enters our body, then our body is prepared, and when that virus or bacteria enters our body, our body's antibodies prevent that virus or bacteria from causing disease. So that is exactly how our vaccines work. That is, they make our body prepared, and that is why all these vaccines are given in when the baby is born, you know, usually in the first year of life, so that the baby is protected against any disease. Now you know that there are various different types of vaccines. So you have basically vaccines which are the killed virus or bacterial vaccines. That means you actually have the virus or the bacteria which is killed, and this killing can be done in various methods. You can either heat kill it, or you can chemically kill it, which is called as a killed vaccine. Or what you can do is that you can actually weaken that virus or bacterium by culturing it again and again, so it becomes weak, in which case it is a live vaccine. So for example, that oral polio drops which are given, you know about the pulse polio, you know that, na? That every year the doctors or the nurses come and they give those polio drops, do boon zindagi ke, that is called, though that is a live vaccine. Or chicken pox vaccine, or the BCG vaccine which is given at birth. You all know that scar on your hand, you know that, isn't it? That is a live vaccine. So some vaccines are killed vaccines, some vaccines are live vaccines, and there are some vaccines actually in which only a part of that virus or bacteria is taken, and that is basically some vaccines like hepatitis B. Have you heard of hepatitis B vaccine? Or have you heard of tetanus toxoid? Tetanus toxoid का नाम सुना है आपने? TT, जब वो तो पक्का सुना होगा, आपको चोट लगती है तो आप जाते हैं और फिर वो TT का इंजेक्शन लगता है. That is like a TT, which is a part of the, उसमें the tetanus जो बैक्टीरिया है वो पूरा नहीं लेते, उसका जो टॉक्सिन होता है उसको इनएक्टिवेट करके टॉक्सॉइड. So toxoid is a part vaccine. So most vaccines are of three types: either it is a killed vaccine, or it is a live vaccine, or it is a part vaccine. So these are the basic three types of vaccines. So after understanding the principle behind the vaccines and the various types of vaccines, let us go through a journey of the how vaccines were developed. Now this concept of vaccine is not just 100 years old or 200 years old. In fact, this concept of vaccine goes back even 500 years ago. And in fact, in the 15th century, the smallpox was the first, it was a very bad disease in the past. So even in this is basically a picture from from Turkey. And at that time, people knew about smallpox, and they knew that if they were exposed to smallpox, they could get protected from it. So you actually have a picture of the Turkish Sultan, and you have a patient who had smallpox, because smallpox would leave scars on your face. So this person is actually getting exposed to a person with smallpox, thinking that if he would get exposed to a person with smallpox, he would get smallpox, and then he would get protected against it. And have you heard that term of rubella parties? Rubella party was a thing when young girls would get exposed to a girl with rubella, so that they would get rubella, and then later they wouldn't get rubella later. So this was a concept of natural vaccination by getting exposed. Of course, what is the danger of this? Can anybody tell me what is the danger? Like, you have a patient with smallpox and you get exposed to that patient and you get natural smallpox. Can anybody tell me what is the danger of this? Anybody here? भाई अगर किसी पर्सन को चिकन पॉक्स है और आप उसको जानबूझ के जाकर उसके सामने जाकर आप इन्फेक्शन ले लेते हो, तो उसके साथ क्या प्रॉब्लम आपको नज़र आती है? कोई बता सकता है? कोई भी? उसका डेंजर क्या है? भाई आपको बीमारी भी तो हो सकती है और उससे आप मर भी तो सकते हो, है ना? एक तो है कि आपको हल्की बीमारी हो और आप प्रोटेक्ट हो जाओ, पर आपको डेंजरस बीमारी हो कि आप मर भी सकते हो. तो वैक्सीन में क्या है कि यू गेट अ वीकेंड फॉर्म ऑफ द वायरस और यू गेट अ किल्ड फॉर्म ऑफ द वायरस, एंड देयरफॉर यू विल गेट द प्रोटेक्शन बट यू विल नॉट गेट द डिजीज. सो दैट इज व्हाई द फर्स्ट attempt at vaccination was against smallpox, and this smallpox was actually a disease which was there for 3,000 years. Smallpox was a disease which was there for 3,000 years, And in fact, this disease was so dangerous that it would kill 1/3 of the people that it infected. And it was a major cause of death between the 15th to 20th century. And you know about this Aztec civilization, maybe you must have read about it. It was a civilization in South America, Incas again, Central and South America, and it wiped out entire populations. The disease was so bad. And in fact, there were estimates that it caused 300 million deaths in the 20th century, means 30 crore people died. And this is the picture of a girl who had smallpox. That means the entire face and body. And you know, you must not be seeing these people, but there would be so many people who survived smallpox, and then the whole body was covered with scars, because when you get chicken pox, it doesn't leave scars. But when you get smallpox, and if you survive it, it leaves scars on your body. So therefore the disease was actually a very bad disease, and it would leave scars. So how did they develop a vaccine against smallpox? In 1796, that means 200 and maybe 50 years ago, there was this person called Edward Jenner. And what he found out was that these milkmaids, they didn't get smallpox. And how he understood that there was another disease of cows which was called as cowpox. And cowpox is a virus which is similar to smallpox. And cowpox, so if milkmaids got infected with cowpox and they didn't get smallpox, so what he did is that he took this cowpox virus and he injected into a boy, and later this boy got ill, but later when he was exposed to smallpox, he didn't get smallpox. So that is how the first viral vaccine was created to protect against smallpox through cowpox. And that was the start of the vaccination, and that was how the smallpox vaccination was created. The next vaccine which was created was by Louis Pasteur. Have you heard about Louis Pasteur? Is there any exhibit here in this museum, in this center about Louis Pasteur? No. But Louis Pasteur, you must have all heard about it. There's a Pasteur Institute in France. He belonged to France. And at that time, rabies was a very dreaded disease. Have you heard about rabies? Have you heard about, somebody mentioned about rabies vaccine. You know that if you are bitten by a dog, you have to go and take the rabies vaccine. Rabies is a disease which is transmitted by bite of animals, any warm-blooded animal. So even if you're bitten by a cat, or you're bitten by a dog, or you are bitten by a monkey, it can be transmitted. And rabies is such a bad disease that if you get rabies, there is no treatment. It is 100% fatal. So that time what happened is that this Louis Pasteur, he was the first one who basically developed the rabies vaccine. And what he did was that he took the nerve tissue of a rabid dog, and he created the vaccine out of that dog nerve tissue, and he injected it into a boy who had been bitten by a rabies dog, and that dog survived. And he was the first one who developed the rabies vaccine. So the first vaccine was developed against which disease? This is to make sure that you all are not sleeping here. Which was that disease? Smallpox. And second was? Okay. And you know this, there's an interesting story that this boy who was protected by Louis Pasteur became the caretaker of Louis Pasteur's tomb in Paris. Okay, because he was so indebted that he became the caretaker of his tomb. Now the third vaccine was developed against flu. Do you know about flu? अभी तो चल रहा है बॉम्बे में. फ्लू में क्या सिम्टम्स होते हैं? क्या होता है? इन्फ्लुएंजा में क्या होता है सिम्टम्स? पता है आपको? फीवर. और क्या होता है? कोल्ड, कफ, है ना? फीवर, कोल्ड, कफ होता है फ्लू में. तो ज़्यादातर लोग तो ऐसे ही ठीक हो जाते हैं, बट कुछ लोग होते हैं जिनमें निमोनिया भी हो सकता है और मर भी सकते हैं. तो इनफैक्ट ये जो स्पेनिश फ्लू हुआ था, दैट वाज इन 1918 to 1919. That means almost 100 years before the COVID-19 pandemic, and it killed 50 million people. That means if you look at it infected 500 people and million people and killed 50 million. And if you compare it with COVID, COVID infected 700 million people and killed 7 million people. So it was almost 10 times more lethal than COVID-19. So when actually, so you know, vaccines are produced out of necessity. Like COVID-19 came, that's why a COVID-19 vaccine was produced. Because there was a problem of smallpox, that's why a smallpox vaccine was produced. Because there was a problem of rabies, that's why the rabies vaccine was produced. When there was a problem of flu and so many soldiers died that who couldn't fight in the World War. You know, this 1819 was also the time when World War I was going on. That is why the US started producing the influenza vaccine, and that is why now we have the flu vaccine. And it took a long time to start producing the flu vaccine. So that is why after the smallpox vaccine, after the rabies vaccine, then we started having production of the flu vaccine. Can anybody tell me after the flu vaccine, which was the next vaccine which would have come? No, no, no. अरे बाबा बीच के 100 years कहाँ गए? इबोला, अरे बाप रे, वो भी अभी आए हैं. उसके बाद आए पोलियो. Okay, because again polio is a very bad disease. We don't see any polio because last 10-12 years में there is no polio in India. But at that time polio was there, and in fact even you have Egyptian, you know about Egyptian civilization, it is also a very old civilization like our civilization. You know, there are 4 ancient civilizations. Can anybody tell me what are the 4 ancient civilizations? Egyptian, Indian, Persian and Chinese, isn't it? So Egyptian civilization के जो images हैं उसमें they show children who are walking with canes, who are crippled, and it was one of the most feared diseases. And if a person would either die because of polio, because of respiratory muscle paralysis, and people who survived would be crippled, and you know 500,000 people every year would die because of polio. And that is why there was an urgent need of vaccine. And what you see here in this picture is a boy. And can you tell me what is there around that boy? What is that? That is an iron lung. Okay, so at that time they didn't have any ventilators. So this is what is an iron lung, because the polio affects your muscles, it affects your breathing muscles. So this is an iron lung for ventilating the baby. Us time this was the kind of ventilators that were available. So this was a very bad disease. So we talked about smallpox being a bad disease, we talked about rabies, we talked about influenza, and now came polio. And that is why there was a need to develop a vaccine against polio. And this is the person, Salk, he was an American, and he developed the killed vaccine. And can you believe it? I mean, these were scientists, and he first tested that vaccine on himself and his family. Look at this. I mean, look at him. Because you know, nobody else was willing to test the vaccine. So he first tested it on him and his family. Then he tested him on other children, and the vaccine was licensed. And look at another greatness of this scientist, that he didn't patent it. Now everybody is in a rush to patent their products to make money, but he didn't patent the vaccine. And when somebody interviewed him and asked him that why didn't you patent your product, he said, can somebody patent the sun, because the sun is giving out light without any thing. So this was the greatness of his man, and it is because of the polio vaccine so many lives have been saved, and so many people have been saved from being crippled. But we all know about the live polio vaccine, because polio, I told you that vaccines can be made by either killing the virus or by weakening the virus. So at the same time, around the same time that the killed vaccine was developed, somebody made the live polio vaccine also by oral drops, by making it in the form of oleo drops. So this was again another American, and he also tested the vaccine on himself and his family members. But at that time there was already the killed vaccine available in the US. So the US people were not interested in testing this vaccine. So then he went to the USSR, and this vaccine was popularized by the USSR, and the WHO adopted the oral polio vaccine as the tool for eradication because it was cheaper. And can anybody also tell me why oral polio vaccine will be more convenient to give? Because again, oral drop is easier to give as compared to an injection. Na? Can you just connect it to the, to power? Yeah. So, we talked about polio, how dangerous a disease it is, and how there are two types of polio vaccines. Now, in our national program, we have both the oral and the injection vaccines. Now, we come to the next. So then we have DPT. Have you heard of DPT? Triple. So, have you heard of these diseases called diphtheria, whooping cough, tetanus? Anybody has heard? Diphtheria. Diphtheria is a disease in which you get this you get a sore throat and you get swelling of the neck. Have you heard about tetanus? I told you about tetanus, isn't it? Tetanus is a disease which you get from an injury, and then you get paralysis of your muscles, and you can get you have something called tetanus is also given to pregnant women, tetanus vaccine, so that the newborn doesn't get tetanus. And this was a vaccine which was developed in 1920s, and then it was combined, and this vaccine is given to all babies so that they don't get these dangerous diseases. Whooping cough is also called Kali Khasi. You have these three diseases are called Galgotu, tetanus and Kali Khasi. So these vaccines are a part of the national program, and these have been given for a long time. Then measles. Measles is the most contagious disease on the planet. Matlab, among all the diseases, it is the most contagious. And if we look at the 150 million lives which have been saved because of the vaccines, measles contribution is 60%. So, of all the vaccines, if one vaccine has been the most useful, it is measles vaccine. And measles comes like with fever, rash and cough, cold. And this vaccine was developed in 1963, and then there has been a program to control measles. And this is a very, very important vaccine, and it is given to all babies at the age of 9 months. And then what happened is, once these vaccines were developed, then the WHO came with a program that smallpox is a bad disease and it has to be eradicated. And I would just like you all to see this film on smallpox vaccination. Can you please click on this link? Can we go down? No. Okay, we'll leave this. Okay, we'll leave the film, I think. No. Can we go down? No. On this side, हाँ. Go down. Go down. और नीचे. 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 Yeah. Can you click on this? Yeah. I just want you to see this film. Yeah.
You might not know me, but you know what I am, what I was. The mighty bull, repulsor of millions, lord of the two lands, sovereign protector of Egypt. Pharaoh, Ramses V. Do not fear my appearance, as I once did. This sickness, it didn't discriminate. All were vulnerable. All were fearful. Even kings. Highly infectious and incurable. Smallpox took the lives of hundreds of millions of people. But humanity fought back. smallpox vaccine became the first ever vaccine, and you administered it with fierce determination. Health workers tracked down the virus, going door to door to chase it out of every corner. 500 million vaccinations were given, forming a ring of safety. The disease was gone, and with it the pain, suffering, and stigma that afflicted countless lives. Including mine. The power of science prevailed. In a disease that had been around for thousands of years, you completely wiped it out. I was remembered as a pharaoh, a ruler of ancient Egypt. Even after death, I was preserved, celebrated. But you will be remembered for this, the preservation of life. If you can do this, you can surely do anything.
So, yes. So this film was just to tell you that, you know, smallpox affected even kings. It affected even Abraham Lincoln had smallpox, and it was eradicated. So this is the only disease in the world which has been eradicated. And now this vaccine is no longer given, but there is a stockpile of the vaccine because it is considered to be an agent of bioterrorism. And now monkeypox, have you heard of monkeypox? So monkeypox is a disease like smallpox, okay? And that is why the vaccine which was made against smallpox is being used against monkeypox, because it can give some protection. So remember, you know, the microbes are smarter than humans. If it won't come back as smallpox, it will come back as monkeypox. Okay. Now, so what the WHO thought was that if they can eradicate smallpox, they can also eradicate polio. And therefore, they decided that they are spending so much money on, small polio. So let us now eradicate polio by giving polio vaccine so that we can stop using the polio vaccine. But it is here that they went wrong, because they couldn't eradicate polio. But still, what is now happening is all over the world, there are very, very few polio cases which are happening. So you can see this is the world map now, and the only two countries where there is polio remaining in the world is Pakistan and Afghanistan. This is what is the area where there is polio. These red dots are just the number of, so there were millions of cases of polio in 1950s and 60s, and now you have a handful of cases of polio. But what is this? What are these dots? These dots are vaccine-derived polio viruses. What are vaccine-derived polio viruses? These are, what happens is oral polio virus, I told you, is a live virus. So it can get converted into a polio virus itself. Can you please click on that link? Yes. Can you move down? Move down. This is something which is important for you to understand why we cannot stop giving polio vaccination. Go down. Go down. Yes. Can you click on this? Yeah.
Polio is an incurable disease that can cause permanent paralysis. Thankfully, there's a very effective vaccine known as the oral polio vaccine, which provides lifelong protection from polio. Each drop of the vaccine contains a weakened form of the polio virus. This helps the body to develop immunity so that the child is protected against polio. Just like the wild polio virus, the vaccine virus can be passed from child to child. This helps spread the protection against polio to other children. even those who aren't vaccinated. However, when a large number of children are not vaccinated and immunity levels are very low, the vaccine virus can continue to spread from one unprotected child to another for a long period of time. As the virus continues to find unvaccinated children, it undergoes small genetic changes. On very rare occasions, this can cause the weakened virus to change into a form that can cause paralysis. These rare virus strains are called vaccine-derived polioviruses. They can paralyze people for life and can even spread to cause outbreaks. This is called a circulating vaccine-derived poliovirus. If immunity is high, vaccine-derived polio cannot arise. That's why it's so important to reach every last child with vaccines. If outbreaks do occur, they can be stopped in the same way as wild polio, with vaccination campaigns that protect children against all types of polio. To eradicate polio, we must stop all types of the virus. Let's make sure we vaccinate every child and end all polio for good.
So that is the problem of the oral polio vaccine, that while it has helped in eradicating polio, it has also given rise to this vaccine-derived polio virus, and that is why now the government is moving from oral polio vaccine to the injectable or the killed polio virus vaccine. So that is to tell you that the live vaccines have their problem. And I also want to tell you that measles is a dangerous disease, and therefore the government of India launched this MR vaccine program. I think all of you must have remembered that you got this MR vaccine in school. Do you remember? 4-5 years ago, you got the MR vaccine, and that was a program by the government of India to give you MR vaccine, to give you protection against measles, and also to protect you against rubella, which is very important for girls, because rubella is not a dangerous disease in girls, but if you get rubella when you are pregnant, then it can affect the baby and it can cause serious defects in the baby. And that is why this MR vaccine campaign was launched by the government of India in an effort to vaccinate 40 crore children, which was one of the largest campaign of its kind in the world. And then you have this meningococcal meningitis, which is a huge problem in sub-Saharan Africa. And this is the meningitis belt of sub-Saharan Africa, and you have this meningitis problem. And you know, this vaccine for protection against meningococcal meningitis was actually produced by the Serum Institute of India. And there are so many other vaccines, but I don't think I have time to talk about them here. You have the pneumonia vaccine, you have the TB vaccine, you have rotavirus vaccine, you have chicken pox, typhoid vaccine, and those of you who haven't taken typhoid vaccine, please take it. All of you eat vada pav outside, I know you do, and if you haven't taken the typhoid vaccine, you'll have that. Then you have, I know, human papilloma virus vaccine to protect against cervical cancer. This is very important for girls and all that. So these are so many other vaccines which are really important. But fast forward and we come to other vaccines which have been recently very important. I think somebody mentioned about Ebola, and Ebola is a very dangerous disease in Africa, you know, which can cause bleeding and can cause death in 50% of people. This Ebola virus vaccine was a recent breakthrough. You have the malaria vaccine, which is again produced by Serum Institute of India. And this dengue, I think you have all heard of dengue, and this is the dengue season now. I mean, if you have high fever, it could either be flu or dengue. And now you have this new Q-dengue vaccine, which may soon come into India. And this is also a very, very important vaccine for India, and it may soon come into the Indian market. So these are some of the new vaccines which are coming. But we all know that COVID has been a game changer as far as vaccines are concerned. And why is it such a game changer? Because you will be surprised to know that, you know, that in COVID, you know which year the COVID virus was, you know, it came in 2019 December. You know that, na? That China started reporting cases of pneumonia. And the genome of the virus was published on 8 Jan 2020. And you know, Moderna started developing the vaccine on 11th January 2020. Can you believe it? 3 days after the genome was published, they started working on the vaccine because they knew that this is a dangerous virus. And vaccines were available 1 year later. So this is something which is completely, I'll show you a graph in the next slide. And different platforms were used for vaccine production than the usual ones, because I told you that vaccines are of 3 types. Either they are the killed vaccines, or they are the live vaccines, or they are part. But here you had different platforms. And India was at the forefront for vaccine development, production and vaccine supply as far as COVID was concerned. And this is just to tell you how COVID was different as compared to other vaccines. Now you look at typhoid. The typhoid bacteria was discovered in 1884 and it took 105 years for vaccine development to take place. It took 47 years to develop the polio vaccine. It took 42 years to develop the pertussis vaccine, 33 years to develop the rotavirus vaccine, 22 years to develop HPV, 16 years to develop Hep B, 10 years to develop measles, and HIV, we don't have a vaccine for HIV till now. And look at COVID, in 1 year we developed the vaccine. Isn't that really remarkable? And you know, you have heard about Covishield? And have you heard about the Pfizer vaccine? You have heard about Pfizer, isn't it? So you must understand that Covishield is a different kind of vaccine. In Covishield, what they have done is that they have used a chimpanzee adenovirus, meaning what? That the adenovirus which is infecting chimpanzees, okay? And they have inserted the gene of the COVID virus inside that chimpanzee adenovirus, so that when you get infected with that, it is a non-replicating virus and you use, and that is how that vaccine is made. So it is a completely different way of making the vaccine. And the other vaccine, which is the Pfizer or Moderna, what they have done is, have you heard of DNA and RNA? Yes. So what is RNA? Can somebody tell me what is RNA? Ribonucleic acid. Okay, so what is the function of ribonucleic acid? It produces protein. Okay, so what they have done is that they have taken the messenger RNA of the COVID virus and they have put it into a lipid envelope. And what does the mRNA do is, it comes into your body, they inject it into your body, and then the mRNA goes into your own cell and it uses your cell's organelle to produce the spike protein of the COVID virus, and then your body then produces antibodies against the spike protein. So the COVID-19 vaccine has used a completely different platform. It is not, of course, the Covaxin. Have you heard of Covaxin? How many of you, of course you are not eligible, but many of your older brothers or sisters must have taken Covaxin? Or your parents must have taken Covaxin or Covishield? Yes. So in India we didn't have Pfizer or Moderna, but we had Covishield or Covaxin. So Covaxin is the standard form of vaccine where they grew the COVID virus and they inactivated it, but Covishield is the one which is a completely different platform. So what was the impact of COVID vaccine? In fact, they have calculated that if these COVID vaccines were not there, maybe another 15 million people would have lost their lives, isn't it? So 7 million people lost their lives due to COVID, but if these vaccines wouldn't have been developed, we would have had an extra 15 million deaths. So this was the impact of COVID vaccines, but right now there are so many newspaper articles circulating that these COVID vaccines were actually very dangerous, people are dying due to heart attacks, etc. But in fact there are some studies which have shown that these vaccines were not responsible for all these heart attacks, etc. Maybe in some people, because no vaccine is completely safe, but remember that the benefits of the vaccines outweigh the risks. So we must understand that while these vaccines have done a great job, they have protected a lot of people, but all vaccines are not free of side effects. They can cause minor side effects. So do you have you all taken vaccines recently? Anybody took an injection? Raise your hand. What side effects did you have? Anybody? Yes. Pain? Pain you had? Swelling, yes. You mentioned it correctly. Pain, fever, swelling. But sometimes you can also get major side effects. You can get an allergic side effect. That is very rare. You get it 1 in million vaccinees. Sometimes you can get paralysis like OPV, you know. If you take oral polio vaccine, because it is a weakened form of the vaccine, sometimes it can become virulent and it can cause paralysis, and sometimes other side effects can happen, especially in people whose immunity is poor. So remember that everything comes at a price. So there is nothing in the world which is 100% safe, but you have to see whether the benefits outweigh the risks. And that is why you have this, what is called as vaccine hesitancy and anti-vaccine sentiment. Like, you know, there are these people, there are these groups, you know, who keep going. They say we shouldn't take vaccines. And in fact, there were many such groups in the US. They say that we won't take COVID vaccines because these vaccines are harmful. This is a pharma lobby which is lobbying. They want to make money. That is why they're pushing these vaccines against us. And I encourage all of you to actually see this excellent movie called The Vaccine War. And this was basically about the development of Covaxin in our country and how this vaccine was developed and what were all the kind of, you know, adversities that they had to face. I mean, it is available on the, I think, Netflix or some such platform. And it's an excellent movie which I would encourage you to watch. So, what is the future? So I talked to you about the past, I talked to you about the present, but what is the future as far as vaccines are concerned? You know, it is, you have to have better vaccine. We are looking at better vaccine delivery and safety. You have to take multiple doses of the vaccine. So scientists are looking at how you can just give a single dose. We are looking at pain-free delivery, like how can we give vaccine just applying a patch, or give all the vaccines packaged into a single injection. We're looking at developing vaccines against diseases for which there are no vaccines at present, like HIV, or we have better vaccines, like we have BCG for tuberculosis, but it is not doing its job well because we are still seeing so many cases of TB. And we have vaccines for treatment instead of just prevention against diseases. And also, so many people are against vaccines, so how can we take care of vaccine hesitancy? So these are all the things that we are looking at. And India is actually very well poised, you know, to take up this, because we should be proud that we are one of the world's largest vaccine producers, and 60% of the world's vaccine production comes from India, and it is the largest supplier of DPT, BCG and measles vaccine, and WHO sources 70% of its essential immunization vaccines from India. And at least if you look at top manufacturers by volume in 2019, 20% is from Serum Institute of India, and this is 9% is from Bharat Biotech Limited and Hafkin. So if you look at this, almost a large percentage of vaccine production is from India. So, I mean, we in India are actually well placed to take up this challenge of vaccine development and manufacturing. So I think with that, I would like to conclude over here by saying that vaccines have been the greatest medical breakthrough of all time, and they have saved millions of lives throughout the world. And there is major revolutionization in vaccine technology, and we have the responsibility to vaccinate. Today itself, I urge all of you to go back to your parents and ask them, ki, have I received all my due vaccines? If I have not received my vaccines, please go to your pediatrician and take your vaccines. And please, I encourage all of you in your audience, whoever you are, I encourage at least some of you to, you know, take this up in your career later. Please, this is a very important thing for our country, that we should be in the forefront later. You know, some of us should go on and develop vaccines against new diseases. Thank you so much.
Any quick questions? Let me ask if anybody has got any questions. Yeah. You want to ask question? You raised hands. Yeah. तो हम क्वेश्चन पूछे. सर पूछ.
अच्छा, कोई नहीं पूछ रहा है तो मैं एक पूछ लेता हूँ. Thank you, Dr. Singhal. I mean, this was excellent. I'm just wondering, abhi, the Indian Pediatric Association has recommended HPV to be rolled out across the country. Why did they choose it only for women and not for both boys and girls? Because it's quite clear now that the same vaccine protects against not just cervical cancers but other cancers also, which are.
So now the IAP is recommending for both girls and boys. It is the current recommendations are to vaccinate both girls and boys.
Okay. So
Yeah.
the IAP recommendation is both boys and girls.
Yes.
But government is giving only for girls.
I think they will also give for boys now, because now the IAP recommendations are to give girls for both girls and boys, and we have started vaccinating boys as well, because it is the vaccination for boys is for two reasons. Mainly it is to protect girls because they are going to be their partners later, and also because it protects boys against anal and penile cancers.
And are we going to see it in Maharashtra soon? I mean, it's not
I
one of the
think so.
pilot states so
Yeah,
far.
but it will come into Maharashtra as well.
So thank you for coming for this. So Dr. Tanu, sir is the director of Homi Bhabha Center for Science. Sir, from the horse's mouth, that is the current chief secretary, made an announcement at IIT Bombay in a public forum that it is going to be extended very soon in Maharashtra. So, I mean, what I have heard, I'm just sharing.
Yeah. Hello ma'am, it was a really interesting lecture. So my question is, when a baby is born, usually most of the vaccines are given within 18 months to 24 months. But if a baby is protected by mother's milk, so is it necessary to vaccinate them so early in their life?
So babies, most of the protection is not from mother's milk, it's through transplacental antibodies, and these antibodies wane with time. So we have to vaccinate them, and that is why we vaccinate. So there is some interference with maternal antibodies, but this antibody protection from transplacental antibodies is also not so much. In fact, that if you look at countries like US and all, they tend to delay their vaccination, so they give at 2, 4, 6 months and 1 year. But in India, we vaccinate them at 1.5, 2.5, 3.5 months, because we want them to get protected early, because the burden of disease is so much. So the protection which is offered by mother's milk and transplacental antibodies is not so much that it can protect them completely.
Good afternoon, ma'am. Is there any disease has no vaccination? If there, then which are the diseases?
So there are so many. In fact, there are more diseases for which there is no vaccination than there is. So for example, right now, like for example, chikungunya, there is currently no vaccine. Of course, there is some vaccine which has been licensed abroad, but there is no vaccine. For Zika, there is no vaccine. Dengue in India, there is no, but there has been licensed outside. So there are many, many diseases for which there is no vaccine.
Good afternoon, ma'am. My question to you is, why are not all vaccines 100% effective?
That's a very good question, because the body's because one is that many of these have many strains, so you cannot have all the strains included. Then second is the immune process may not be 100%. Third is your immunity tends to wane with time, so you cannot keep boosting that immunity always. Third is that sometimes the bacterial or viral load which you are faced with can be so massive that your immune response may not be effective. So the degree of protection afforded by the vaccines can vary anywhere from 50 to 90%.
Thank you, ma'am.
Good afternoon, ma'am. I'm Vanshika. My question is, some vaccines are available which need booster shots, like COVID vaccines also need booster shots. Why is that so that vaccine can't work on their own and they need booster shots?
So it all depends on the type of vaccine. So for example, live vaccines generally don't need boosters. So for example, your MMR, your chicken pox, your yellow fever, these are the live vaccines. They don't need boosters. But your killed vaccines, they generally need boosters because the immunity tends to decline with time. So as time passes, the immunity goes down, therefore you need to boost up the immunity.
Thank you, ma'am.
Good afternoon, ma'am. Is the vaccine is completely safe?
No, vaccines are not completely safe, but but most of the vaccines have only very mild side effects like pain, fever, etc. And the incidence of serious adverse effects is very low. Like for example, 1 per million vaccinees. So if you look at the serious adverse effects with the COVID vaccines, then they were 1 per million, like the clotting in the vessels, etc. If the serious adverse effects with vaccines are more than 1 per million, then those vaccines would not be licensed. Because if you're giving a vaccine or any intervention for prevention, then it has to be very safe, otherwise people would not accept it.
Thank you.
Most of the vaccines may have minor side effects which are frequent, but the serious side effects are very rare.
Yeah, good afternoon, ma'am. I want to ask how much vaccines can be sustainable, like in case of mutations. Many bacteria and viruses, they tend to do mutations, adaptations. So how sustainable?
So that's an excellent question. So that is like good for flu, because influenza keeps mutating. That is why you need a vaccine every year. And that is why the scientists are now looking at how to make a vaccine for which you don't need to change every year. And that is very true for COVID, because what has happened is COVID is constantly changing and they have to keep revising it. So one of the future for vaccines is how to make a vaccine for which you don't have to keep changing it. That is one thing which needs to be, innovation needs to be there. And for example, pneumococcus, you have 200 serotypes and you can't keep making vaccines for all the serotypes. That is a challenge for which we need innovation.
And ma'am, also one more thing, I have always been wondered, like we have been, producing vaccines for many diseases, then why can't we have on HIV? Like what's so special about HIV
so
virus?
that is a challenge because they have not been able to make a vaccine against HIV. There have been many challenges. I don't know why, but they're still looking at why they can't. I think it's one is that as soon as the virus enters, it just goes inside the cell and hides. So they've not been able to make a vaccine against it.
Yeah, thank you.
Hello ma'am, good afternoon. My question is, what is the difference between antibiotics and vaccine? Because sometimes, like during TB, BCG vaccine, it doesn't work. So doctors give antibiotics, right? That we don't take again BCG vaccine like we have taken in during childhood.
So see, basically vaccine is preventive. So basically it prevents the disease from happening. Whereas antibiotics are actually therapeutic. They work after the disease has happened. And to answer your second question, there is now, people are looking at BCG revaccination. So in fact, the government is looking at whether we can give BCG vaccine again to help in reducing the incidence of TB, and I think there is some trial happening for that.
Okay. Thank you, ma'am.
Good afternoon, ma'am. Why do the children below 14 years are not allowed to have Covishield vaccine?
Because it has not been studied below the age of 18 years.
Okay.
And also, to answer your question, COVID is a very mild disease in children. That is why I think our government decided that they will not go for a COVID vaccination program below the age of 12. And I think that was a very good decision because we don't want to give vaccines which could have potential side effects to children where the disease itself is very mild.
Yeah, yes, ma'am. I have a question. This Human Genome Project, in fact, we also had one exhibition on that. And there was a lot of, hue and cry, you can say, that once the genome project will be completed, there will be a lot of genome-based vaccine, customized vaccine, whatever. Means if they know my genome, they can find out, okay, what can be the best. But I think 2013 or so it was completed. It was declared that it is mapping has been done for human. But still, I think 11 years, 12 years down the line, we have not heard anything about that. So, any comment on that?
No, I don't think. I think the closest we have to customized therapy is for cancer-based therapy customized to your genetic thing. But I don't think, So there's, as far as I know, nothing based on customized vaccines.
There were some hopes, like we created also some simulations. Like, okay, this is the disease, this kind of structure it has, so you make a like key and lock kind of arrangement. Okay, it fits and then it takes it away from the body, something like that.
Ma'am, my question is that is the vaccine only weapon for humans against the diseases?
No, there are so many other things that can be done. See, you have to have a holistic approach. Better air quality, better sanitation, better water quality, clean air, better nutrition. All these things are there, need to be there for protecting humans from diseases. Vaccine is only one of those things.
And what about nanotechnology?
I'm sorry, I wouldn't be able to answer that question on nanotechnology. Yeah.
Good afternoon, ma'am. My name is Akshara. So my question is, what is the risk and the benefits from the vaccines?
So as I said, the benefits are that you get protection against diseases which could make you very sick or could kill you. And the risk would be, one risk would be the cost of the vaccine. Of course, vaccines are highly subsidized and funded by the government. The other risk would be the minor side effects like pain, fever, etc. And the third risk would be you may be unfortunate to get one of the rarer serious side effect, which is very, very rare, but nevertheless could happen. Like 1 in a million adverse effect. Like, for example, with Covishield, 1 in a million people got that rare side effect of clotting in the blood vessel. Now, that rare side effect is 1 in a million, but you could be that unfortunate 1 in a million thing. So that would be the risks of the vaccine.
So, with your permission, can I add to that?
Yes.
So, whoever asked on nanotechnology, right? Just remember कि ऐसे कुछ शब्द होते हैं जो लगा सकते हैं कहीं पे भी, right? Nanotechnology is what? Everything in biology, everything in all these things, the size of the virus is 20 nanometers, it's everything in there. If you're working on a spike protein, if you're working on an mRNA, if you're working on anything, it is all nanotechnology. 20 साल पहले, 40 साल पहले, we never thought it was nanotechnology. Just remember that आपने जो figure देखा इधर 1 year for COVID vaccine and 100 years for typhoid vaccine, that is also because for the last 50 years people have been working on different things, not thinking कि हाँ 50 साल बाद ये मेरा vaccine में काम आएगा. They have been doing basic research. How do you get the vaccine inside you? You need a lipid nanoparticle for that, right? You need some cage in which I can put this thing. उसको अंदर जाना है body में without getting degraded by the body. So people have done work, they never called it nanotechnology, but it has always been working on things which are nanometer scales in size, chalta rehta hai. And can I add to HIV?
Yes.
So one of the reasons the HIV vaccine is so difficult is because the HIV virus tends to go inside the DNA of your cell, which means your own body's defense mechanism, the T cells, will not recognize it, which is why it's very difficult. And also, सब कुछ पैसे का खेल है. You have to put money into it. Now you see that making a vaccine is so difficult, but there are other things which, not today's topic, monoclonal antibodies for example, which have also been shown to be very effective for some diseases like HIV, and there's a lot of work in that. So people are looking at treatments or looking at ways to counter it, which may not necessarily be always be vaccine based. Vaccines are still mostly for prevention, and yes, hopefully 2030 or something, people say that HIV ka bhi aa jayega. But it's not that easy.
And another important point I wanted to say is that many of this vaccine development is also money driven. You know, people make vaccines where the money is. Now, COVID, people saw money, so they hurried and made a vaccine. Many of the neglected tropical diseases, people don't make vaccines because there's no money. So that is also a factor where about which influences the development of vaccine. And in fact, you will be surprised to know that this year's Nobel Prize for Medicine 2023 went to the lady who actually developed that mRNA nanotechnology. How the, you know, how to make that mRNA stable or something. That was that Nobel Prize went to that lady who worked in basic research.
Excuse me, miss. I have a question that you said the all vaccines have some side effects, but why the vaccines give us side effects?
Because that is the nature. Like, you know, for example, when you inject something, see, I didn't tell you this, but that vaccine that has some aluminium salts inside it, it has preservatives. Why do they put those things? Because when the vaccine is injected, they need to have some inflammation inside so that the blood can flow to that area. It can bring those white cells into that area for the body's white cells to recognize it. So that pain and that swelling is a must for the immune system to recognize it. So that is part and parcel of the whole process.
Thank you, miss.
Good afternoon, ma'am. My name is Dikshan. I have one question. There is cancer in our country and many people are died. What is the reason of that?
It all depends on what is the cause of cancer. There are many types of cancer. So lung cancer is because of smoking.
But there is a vaccine of the cancer, that's why only.
But there are only certain types of cancer for which there is vaccine. So for example, for liver cancer due to hepatitis B, we have a vaccine, hepatitis B vaccine. For cervical cancer, we have the HPV vaccine. But for many different types of cancer, there is no vaccine. So for example, for lung cancer, which is due to smoking, the vaccine is to stop smoking. For head and neck cancer, which is due to tobacco, the vaccine is to stop tobacco use. Yeah.
Excuse me, ma'am. I have a question to you that Ayurvedic medicines are better or vaccines?
So it is like comparing apples with oranges. Yes. Okay. Yeah, so the thing is that, I mean, I don't know what the Ayurvedic medicines are for, but they will not be able to substitute for vaccines, isn't it? If you have to protect against measles, you obviously will have to take measles vaccine. The Ayurvedic medicines will not do the job, isn't it? So every medicine or everything has its own role to play. We cannot say that if I have to protect against measles, I will take this kala and that will do the same job, isn't it?
Thank you, ma'am.
Good afternoon, ma'am. My question to you is natural immunity better than vaccine-acquired immunity?
So there is some data to suggest that natural immunity may be better and more long-lasting than a vaccine-induced immunity like COVID. So studies show that people who got COVID naturally had better immunity. But the problem with that is that it comes at a price. Because if you get the natural infection, it may be severe. Okay. So that is the problem with natural immunity. So you would rather get the vaccine-induced immunity than the natural immunity. But let us say you had the natural immunity, you didn't get a severe infection, then it's a good thing. Yes. I'm so happy that the children are asking questions.
Good afternoon, ma'am. My question is to you is what is herd immunity and how does it work?
Very good question. So herd immunity means that suppose there are so many people in this room. There are some people who are vaccinated and there are some people who are not vaccinated. So the people who are not vaccinated are protected by those who are vaccinated. That is herd immunity. Because what happens is that the people who are vaccinated, they result in reduced circulation of the pathogen. Because the circulation of the pathogen decreases. So that is why the people who are unvaccinated don't get exposed. So that is herd immunity. Yes.
Sorry, but if it's possible, could we ask the audience one question?
Yes.
Because this is something which we are studying right now, and we find that in Mumbai, people just do not know about HPV. So can we just see how many, you showed human papilloma virus or something. How many people have heard about HPV? Not HIV, HPV. कितने लोगों ने सुना है HPV के बारे में सुना है? क्यों ये एक वैक्सीन है जो शायद आएगा अभी. देखो आपको जो भी वैक्सीन ये DPT के 3 टीके दिए गए थे आपको याद नहीं है, आप सब तब बहुत छोटे बच्चे थे. लेकिन अभी आपको शायद कोविड का वैक्सीन याद है क्योंकि अगर आप 15 साल के थे तो राइट, या 12 साल जो भी है. अभी एक वैक्सीन आ रहा है जो आपको मिलेगा एज अ टीनेजर, राइट. लेकिन HPV के बारे में देखिए, दिस इज वन थिंग वी नीड टू टेल पीपल कि HPV है क्या है. I know the last Friday.
But I think this was not for this group of students.
No. It was for teachers.
But none of them have heard.
See, none of them have. So we need to do a show of hands. No hands. किसी को HPV के बारे में पता है?
अभी मैंने बोला कि cervical cancer है, उसके लिए एक वैक्सीन है HPV, but they don't know. I think they've not heard about it.
अब ठीक है, हम लोग थोड़ा अगर क्वेश्चन है तो बाद में मैम से मिलते हैं. लेट्स पुट हैंड्स टुगेदर टू थैंक मैम. इट वाज अ वंडरफुल लेक्चर और सभी लोग आसानी से समझ पाए इस तरह से उस लेवल पे आके मैम ने एक बहुत ही, बिकॉज टॉपिक थोड़ा डिफ़िकल्ट होता है तो सच में चैलेंज होता है इस लेवल पे आके बात करना, एंड दैट was delivered in excellent way. And I suppose everybody has enjoyed the lecture, are taking a lot from the lecture, right? Okay, so this will end this session, but हमने आप सभी लोगों के लिए एक और सेशन यहाँ ऑर्गेनाइज किया है. हम 10 मिनट्स का ब्रेक लेके हम फिर से यहाँ आएंगे. आप लोग 10 मिनट्स का ब्रेक ले सकते हैं अगर किसी को वॉशरूम वगैरह जाना है तो. सो विल बी हैविंग lecture science demonstration here on liquid nitrogen, matter at low temperature. So it's going to be a very, very exciting demonstration for all of you. And